Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on December 4th, 2025, just yesterday. It introduces a unified ecosystem that automatically builds massive, diverse, and realistic environments for training an agent model called Nex-N1, which then consistently outperforms state-of-the-art open-source models and comes close to top proprietary systems on complex agent tasks. The paper is titled Nex-N1. Agentic models trained via a unified ecosystem for large-scale environment construction, and the implications for how we train future agent models are quite significant. Figure 1 shows that Nex-N1 is consistently near the top of the pack across a wide range of agent and coding benchmarks. The full grid of bar charts compares Nex-N1 with frontier proprietary models like Claude Sonnet and GPT-5, as well as strong open-source systems. In the top row, on benchmarks such as GAIA2 and Tau2 bench, Nex-N1 ranks close to the leaders, which signals strong general agent capability. On SWE bench verified, Nex-N1 matches or slightly trails the very best model, so its code reasoning is clearly competitive. The bottom row, covering tools like Terminal Bench, Backsbench, and BFCL version 4, shows Nex-N1 outperforming most open models and landing solidly in the frontier cluster. Figure 2 explains how the system turns a plain language description of an agent framework into high-quality training trajectories. The top band shows Nex-A4A, which converts a written framework description into structured configuration files and concrete agent definitions. The lower left block illustrates the information fusion query synthesis module that generates diverse, difficulty-controlled tasks. The central Nex-AU engine then runs multi-agent graphs inside simulated environments, and the rightmost column converts raw executions into cleaned, quality-controlled trajectories ready for training. Table 1 makes the headline result concrete. Across 6 demanding agent benchmarks, adding Nex-N1 training consistently boosts the base open models into or near proprietary territory. This table lists models as rows and benchmarks as columns, so each cell is a single score showing task success. The top block compares frontier proprietary systems, which set the reference performance. The middle block shows large open models, where the Nex-N1 tuned DeepSeek variant jumps notably on Tau2 and BFCL version 4. The bottom block highlights sub-100 billion models, where Nex-N1 upgrades UN and intern LM into much stronger all-around agents. Figure 4 shows that human evaluators often preferred Nex-N1 over strong baselines for real project-style coding tasks. The stacked bars summarize how often Nex-N1 won, tied, or lost in head-to-head comparisons. Against Minimax M2, Nex-N1 won about 38% of scenarios with very few losses. Against Kimi K2 Thinking and GPT-5, Nex-N1 wins form the largest single portion of outcomes. Only with Claude Sonnet 4.5 does Nex-N1 have a more balanced mix of wins, ties, and losses, which still reflects broadly comparable capability. Figure 6 shows how the Nex-N1 based deep research agent stacks up against other commercial research agents on the deep research benchmark, which scores systems on end-to-end web research and report quality. The tall blue bar on the left is Gemini 2.5 Pro Deep Research with about 50%. The next bar is Nex-N1 Deep Research at 47%, sitting slightly above OpenAI Deep Research and Claude Research. The middle cluster of bars contains a range of strong but clearly trailing systems, from Kimi Researcher down through Grok Deep Research. The rightmost bars show older or lighter research agents, which fall to around 30%, so Nex-N1 lands firmly in the top tier. So the big picture is that Nex-N1 shows how automated, large-scale environment generation can measurably upgrade agent skills, pushing open models close to frontier systems on real tool use, coding, and research tasks. The broader implication is a path toward continuous, gym-like self-improvement for agents. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.